Wah. Sent to the future from the year 2000 by a glitch due to the Millennium Bug, I'm adapting to thrive in the peculiar conditions of the 2020s. Join me in the multimedia extravaganza as we surf the World Wide Web, catch up on 2 decades of video games and mess around with creative tools new and old. I'm Millennium Cyborg, welcome to the new millennium. Welcome, Haseo. Yeah, I have been diving far too deep into rendering things again. So I'm allowing myself another development stream as a treat. And a slightly different setup. I'm back to my PNG tuber to make it easier to I know people who actually have their avatar going during the development of the app itself, and the more I've tried it myself, the more painful it seems to actually make run. The cleanest, I mean, I'm not even going to get into it. It's much easier to do it this way for now. Alright, so what have I been up to? A few things. First of all, so I had a blur implementation that was doing a Gaussian blur using a separable kernel, so 2 passes, 1 vertical, 1 horizontal, which is okay, but the quality wasn't great because in order to get a big enough kernel, a big enough blur effect for the things I wanted to do, I was rendering the blur down to a render target that was 1/4 of the size of the screen, and when you scale that back up it's quite noticeable. So I did some research. I looked at, actually I'll bring up the article, so it was Intel Kawase blur. So it's this article, an investigation of fast, real-time GPU-based image blur algorithms. Tom, welcome. Thank you. It's a lot of it is actually not as fancy as it seems. For instance, here, I mean the algorithm, the way it works is a bit of a bit of black magic, but it's a blur done in multiple passes with where you only need to do 4 samples per pass, and doing certain patterns approximates a Gaussian blur of a certain size, so you can kind of do a best fit, and each individual pass is only doing 4 samples. So for example, in this example, we've got a 5-pass filter with these are the distances along the diagonals of the 4 samples we take. So we're doing 4 times 5, 20 samples instead of a 35 by 35 Gaussian filter. In the separable version we'd have 35 plus 35, so 70 samples. It's way cheaper. You can only approximate, a few given sizes of blur, but the sample code that comes with this is an GLSL example, or the author has already fit a certain number of sizes of blur. I ported it to HLSL and wrote the code to drive it in C#, and it worked first time. It's just mind-blowing to me sometimes how much easier it is to work in C# compared to C++. So that looks like this. Why is the music stopped? There we go. That looks like this. It is a bit of a PS2 loading screen vibe. So this is a pretty good looking blur, right? So this is rendering to I downscale the entire camera render to a render target a quarter the size, a quarter of the area, so half the size along each dimension. I do one of those sets of Kawase blur filters and then scale it back up, and it's very cheap. It costs like 0.1 millisecond or so, 0.2 milliseconds, and I think it looks pretty nice. And so I'm also using the same effect now for my screen space game-based lighting, but oh no, correction, I do have a way of showing that now, because I added a quick hack for that. So I added a demo image that I can toggle. It's on already, so I should just be able to turn it on. There we go. Is there a Z buffer with ray tracing? So with pure ray tracing, there's no Z buffer. It's not necessary, but you could write to one if you're combining different passes, which there are many reasons to do. Then you can, yes. And so in fact, what I'm going to work towards, I made a meme tweet about it. I riffed on a drill tweet. Hang on, let me bring that up in OBS while I'm talking about it. Oh well, I'll bring it up in Chrome. This is the drill candles tweet, right? I just ripped it off, and but my ray tracing path, it's funny, the existing tools within Unity, within the NVIDIA Nsight and so on, are all for various reasons failing to give me good answers. But I can tell by just doing things like only doing the ray tracing every other frame, I can tell that the ray tracing is 100% of my effectively 100% of my render time. Yeah, I want to run it alongside OBS, and ideally a game on the same machine, and run it, yes, at 60 FPS. The cost depends a lot on what I'm doing in the scene. So I've got some timers here in Unity that these only actually work if I'm running the application outside of the editor. But I can get at least the overall GPU time spent per frame, and then I can toggle various features and see, well, how long does that really take? So, for instance, Hey Loz, we are doing some programming. Very exciting. So it's quite expensive to render everything ray traced, right? And I'm not just doing ray traced reflections at the moment, I'm doing ray traced shadows, which means that for every point, for every light, I'm casting a ray to see whether the light is visible, whether we hit an obstacle, and ray traced reflections and ray traced refractions. All of that is quite expensive. Now, I want to keep the look that I have, but my idea is to do what's called hybrid rendering, where for the very first step of the rendering, the casting of the primary rays from the camera out into the scene, actually you can get the equivalent result by doing a conventional forward rendering pass of the polygons, in which case you can benefit from your normal culling of what's visible to the camera. You can benefit from the GPU being very good at doing polygons, and then you can still say, in order to light those polygons and in order to do reflections and refractions, you can still cast rays after that. There is a DirectX Ray Tracing 1.1 spec that I don't fully know the status of, that would allow for a conventional shader to then cast a ray recursively, but I'm going to work on the kind of current day standard way of doing things, which is going to be to render your polygon scene to an intermediate buffer called a G buffer, which is also called deferred shading. And that intermediate buffer is going to store for each pixel what is the depth, so the Z buffer, also a stencil bit, like I've got stencil bits for is it an avatar or not, avatar material or not, and things like that. And then the material properties that you need in order to shade that pixel. And in a physically based rendering pipeline, that would be a certain set of properties that you can either express in terms of like metallicity or there's a few different formulations of what's kind of a standard physically based rendering setup. My shading model is based on what was implemented in the Bryce and Lightwave renderers, ray traced renderers from, the late 90s, early 2000s. So the materials that I've got have slightly different properties, and so we're going to design a G buffer that can hold those particular material properties that we can then feed into a subsequent ray tracing pass that is just going to be doing, from the camera's point of view, doing secondary rays. That's the idea. On paper, it is a simple matter of software engineering. There's lots of scope for messing things up, because the errors that you might get could be a bit mysterious. If you're writing the wrong thing into the pixel data, it'll not be obvious that it's what's happening. So the materials can't remember. You can get to this problem where you've zoomed in too far in Unity's editor view, and like that it doesn't work the way you expect anymore. And there's a way to reset it, and I don't remember what it is. Was it just like focus object? Yes, that's it. F. Alright, so looking at my models, materials, what's going on? That's okay, I don't know how I did that. Something slightly messed up there with the view matrix, but alright, so the skin material as an example. So we've got a base color. We've got a luminosity, which is an emissive property. I actually need to slightly refactor how I do ambient and luminosity. So I've got my skin has got a bit of luminosity there, whereas I think what I want is to give it ambient. Let's see. I'll worry about that later, but. So it's fully diffuse. We've got a specular value, a roughness. So the amount of specular is how much of a specular shine you get. The roughness is how sharp the specular shine is. Tom, thank you for the subscription. Much appreciated. The reflectivity is separate from the specular value in this model, and I've actually split out. So in one little trick to improve the performance of the where to start this explanation. In general, branching in a shader has some cost, and that's been the case ever since the early days. The cost is much less nowadays, but it's still not as good as not branching, right? I just need to swap my headset batteries. In particular, the NVIDIA recommendations for ray traced applications. Oh, Bentai, thank you for the raid. Welcome everyone. This is not my usual streams. This is a development stream. I'm working on my own rendering engine for my avatar, and it's fully ray traced. So I'm currently working on optimizing the performance. Can I get a bit of camera action here? Here we go. I hope your flight went safely after the part that I saw. Your program crashed. Oh well, that's so you got at least 2 different kinds of crashes in one stream. Rays are definitely being traced right now. So right, so NVIDIA recommends not having conditional raycasts in a shader, and I had a test saying, well, are we reflective? If so, trace array. If not, do this. I found a slight performance improvement by making it a shader keyword. What that means is Unity will compile 2 different versions of the shader. one with the property turned on and one with the property turned off. Wow, that looks bad. So you have to turn on reflection as a feature now, and then you can also set the amount of reflection. Index of refraction is purely for transparent materials. Metallicity in this model only controls the extent to which the reflection... I don't want music with lyrics in. Hold on. Yeah, I found a few playlists of supposedly DMCA safe drum and bass on Spotify, but I need to create my own because I just don't want the ones with the lyrics because I can't talk while those are going. What was I saying? The metallicity in physically based rendering models, it controls other things. For example, not again. The balance of specular versus diffuse. Whereas in this model, I can have an unrealistic combination of diffuse and specular in a material. The metallicity just controls to what extent the base color is a tint on the reflections and specular highlights. Yeah, the T-pose, I could fix the T-pose, but in any case, I wasn't intending to run with full tracking. Let's see, I can do a quick bit of VC face. There I am. Okay. So I've got a few new things. I've got this additive property, which it's kind of a hack at the moment. This place was a trap. The first few tracks were fine, and then hang on, I've got a few other playlists I can try. No. No, everything has lyrics. Sorry about that. What can I do? Can I... I'll just keep skipping for now when there's lyrics. Right, I've got a few hacks in there, features that aren't fully supported yet, like an additive blend. Additive blend, potentially expensive with ray tracing and with other rendering models, really, to be honest. Transparency and that sort of thing. Always potentially an issue. Right, so as the first step, to making this something that can work with a deferred shading model, as the first step, we want to have a intermediate representation of the bidirectional reflection distribution function at a point, or rather the R model for it. So what that boils down to is I want a struct that contains the single point values for all of these things. But for instance, we've got a color map here, and we have a texture. We won't be holding the we'll be sampling the texture and multiplying through the base color. So that point won't need any texture lookups. And then that point can be what we then write to a buffer later. I hope that was a coherent explanation. Usually it's just all in my head. I don't talk about these things out loud except on stream these days. So in terms of the implementation, I've got a few different materials. Well, I've got quite a few materials. Most don't even use texture. So these are then using a small number of shaders. Most of these are unused currently. Let's see, where are we? Visual Studio. Yeah, there are two of me. It's okay. I'll keep one hidden while I'm in here. So the skin material, for instance, uses just the standard surface shader. The other important one is the transparent one. The only big difference between these is whether or not they have an AnyHit shader. So in ray tracing APIs, we have the closest hit shader, which gets called once we've determined that that we have the closest hit along arrays in a particular mesh with a particular material. The AnyHit shader is invoked at potentially anywhere along the ray. It might not be the closest hit along that ray. In the AnyHit shader, you get to say, actually, my material is transparent at this position. Please ignore the hit and keep going. You can also do partly transparent materials, but the sort order along the ray is not guaranteed. So I do transparency instead by casting a subsequent ray in the closest hit shader, which is more expensive but more correct. So what we're doing here is so in materials that use this shader, there's a weird thing I found, which is in order for the ray tracing subshader to actually pick up the AnyHit shader, up in the non-ray tracing class, I have to add the render type transparent tag, whereas in the regular one, I have the render type. Wait. Oh, this is some other thing I was doing. Sorry, I end up with lots of prototype code in there. This is for the this is for non-screen space or world space illumination stuff I was trying to do. But in theory, this should be gone and this should be opaque. Actually, I should remove that stuff because I'm not using it and it's expensive. There we go. Let's make sure that, yeah, that's still working. So then each of these has common properties. I've got a few special purpose materials as well. One is for the thrust of my racing, futuristic racing Friday racing ship, the Dream Chaser, I've called it in here. And we've got one special one for water, but that's not actually used in the current scene because the water is executing as part of the mist shader. This is if I want an extra water plane somewhere. So the only things that are really being used here are, and the glasses one I'm no longer using a separate one for the glasses. So we're only using the default surface, the transparent, and the spectrum one, which has to do with extra procedural nonsense to render the you know, the spectrum lines behind me there. Hey Ryan, good to see you. I'm explaining the stuff that I will do in terms of development today. I haven't gone around to doing any real development yet. So I've got some common code for my, so ignore the spectrum one for now, going to just the surface shader. Right now the way it works is, so we have this invocation here. I've got, this is like some debug tracing stuff. I can trace the path and child rays of a given array. At the hit point we get, we are supplied with the barocentric coordinates of the intersection point. So those are the coordinates within the triangle, within the polygon. We use those to interpolate the various attributes of the vertices. So we get things like normals. We get things like normals, vertex color if there was any. What am I actually doing? Normals, UV. Let's find the actual implementation of that. So the vertex positions, the normals, the tangents, you know, I'm still not 1000% sure when you actually need tangents in your shader and when you don't. I think it comes down to anisotropic materials, but that might not be the only thing. So anisotropic means not the same in all directions. Normally you'll have the normal of a point on a surface on a polygon, either through just the normals of the vertices interpolated or through a normal map. But you want a full 3D basis. You want to know, usually you need 3 directions to form a local space that you can do, you know, various effects with, reflections and whatnot. Well, not reflections, you just need the normal for those. But if you need a local direction, then you need a tangent. If you need to know a direction along the polygon, and you could pick an arbitrary one. For instance, you could pick the direction of the UVs. I guess what I've not fully grasped yet is, why is it not sufficient to just use the direction of the UVs? But I'm sure as I continue to read more about this stuff, I will figure that out. Anyway, texture coordinates, we tabulate as well. And then, so I've got a common function for all my materials. Which is where we're going to be working for now. How much of what I was just saying was intelligible because I wasn't showing the code? I think it was fine. Alright, this is the meat of the code that does the shading. And it's very hacky. It's where I do a lot of experimenting with how it's all working. What I want to introduce, and I might have declared one somewhere already, I might have commented that out. I want to introduce a new struct. Probably need it in this common file. We've got range section, attribute data, and a few utility nonsense functions, and it's also the common data buffers. It's probably a cleaner way to organize all this. But let's do this be bidirectional reflections distribution function. In the Unity code and elsewhere, I've seen this name used for this type of structure. I can't tell if it's a misnomer or not. In theory, the bidirectional reflectance distribution function is the full equation of how much, given an incoming direction and an outgoing direction, at a point on the surface, how much reflection is there for a given wavelength. But in reality, you can't model that, perfectly. So you create a model that usually, you'll limit yourself to just red, green, and blue channel wavelengths, and also you won't model that. You'll model the reflections as, say, a lobe reflection, where you just have a reflection going in one direction, or one direction with some amount of jiggle. And so this represents that parameterization for a given point in the world. So I'm just going to copy this stuff, and so I'm also going to, I don't know if you would call the stencil buffer bits a part of that or not, probably not, but I'll stick them in there because it's useful, and this will be part of what goes into the deferred buffer. However, the textures are not. For instance, in the deferred buffer as well, we'll have a limited, in the G buffer, we'll have a limited amount of space available. The position doesn't need to be encoded, because we'll get that from the depth. And actually, that's a point. Maybe I don't want the stencil in here. I'll leave it off for now and think about it later. So in that buffer, I'll have a limited amount of space. It's a lot of information stored per pixel across the entire frame. So I just saw your comment to say absorbance. Right, yes, the kind of the absorbance is the opposite of the reflectance when it comes to the BRDF. So we don't need these. And actually, let's have a look at what the Unity gbuffer implementation looks like. So gbuffer Unity. So this is the built-in renderer is using, hang on, I'm trying to get it to pick up Chrome. There we go. Okay, so in the universal rendering pipeline, I think these are pretty similar for the different pipelines, but we only get, in a given render target, we only have a certain amount of information we can write per pixel, so you have to use multiple render targets, and then you want to break that up. You want to use as few bits as possible per pixel. So here we've got albedo, specular, both RGB. We've got the encoded normals, emissive, and then we've got the depth stencil buffer is a standard thing. The depth stencil buffer is so they're commonly allocated into one buffer. The depth and then the stencil bits. So we'll have, for example, 24 bits of precision for depth, and it'll be organized so that it'll be floating point values with... Yeah, I need to curate it. I don't actually usually use Spotify. I use my own playlists when I'm listening to music for myself, but this way I've got something that someone else at least certified as DMCA safe. The laws are saying, don't think I heard you comment on the matter. Got any concerns about Unity partnering with what's said to be a malware production company? It's concerning, but I think it's not quite the case that they're going to be, stuffing malware into Unity. There's also not exactly a lot of choice in the industry right now. As I understand it, especially for targeting mobile platforms. For a lot of people, it's Unity or nothing. Yeah, I think people are probably more concerned about the long-term trajectory of Unity rather than the immediate fact of that acquisition is I don't even think it'll have noticeable impact for anyone, to be honest. It'll just be, it's just an ad platform, yet another ad platform and an analytics platform thing. But we'll see. I may be wrong. Yeah, like you say, it's not that you'd expect malware in Unity. It's that it's very bad, a bad look for them to partner with a company that is famous for having produced malware in the past. The main complaints about Unity I see on Twitter these days is about how hard it is to finish a game. It's easy to get started and very hard to produce a finished product. I'm not really at that stage yet, so I'm not familiar with that aspect yet either. NFTs, yeah. Although, I mean, most of the places NFTs are integrated, you know, you can completely ignore them. Yeah, I mean, I'd be surprised even if they wanted to, if Unity would be able to do a kind of info gathering that in an unwanted way without developers' knowledge. I expect what will happen is they'll add new features in Unity, new packages for collecting information that you can't currently get, and probably mobile app developers and so on will turn it on and use it to improve their monetization strategies and all that, but right, so so I'm gonna conceptually want to group these into sets of 4. Get that feature. Can ignore alpha clip. Alpha clip doesn't need to be here because we'll have done the clipping already. Alpha clip is when you say if the alpha ends up below 0.5 or below the alpha clip value, then treat it as fully transparent. If it's above, then treat it as fully opaque. Receives haze and additive. I'm not going to think about those for now. I mean, some of these are floats because they use that tagging feature I mentioned earlier. But so they're just single bit feature flags. And it's in this. I'm just gonna write flag. This is fine actually. And then we want a float 3 normal. Not sure about tangent. Not sure about. I have. I read breakdowns of various engines, how they render a particular frame. I haven't seen any tangents in gbuffers. 32-bit bool, yeah. We'll condense that to a real flag. Oh dear. What else can I do music-wise? I don't want to have one BGM looping forever either. And that I found a mix on YouTube previously that was pretty good, but did trigger, well, you know what? It triggers the YouTube copyright police, but not that doesn't affect me really. Since I'm not monetized, and it doesn't trip anything on Twitch, so let me make sure that's picked up. Why is OBS not seeing Fubar anymore? Just restart it. Restart Fubar. What? OBS does sometimes just do things. Okay, fine. I'll do desktop audio capture. There we go. Get some lo-fi hip-hop instead of drum and bass. So we've got 1, 2, let's say like we stuff the flags in there. So there's going to be Unit 8 flags. So that's one render target, another second render target. Is Unit 8 not a type? There we go. Not a type in HLSL. Yeah, that looks good. So we've got 4 render targets, an entirely reasonable number to be working with. Plus depth stencil, yeah. So I'm going to handle transparency. Transparency is a problem if you're doing deferred shading. I'm going to handle it the expensive way by just treating the materials as first of all opaque, but then casting a refracted ray through them. If they do that, if the material does that. Alright, so now what I want to do is in my surface shading function here, I want to split the work into 2 parts. One is figuring out that those BDRF values, and the second part is going to be calculating the actual pixel shading using those values. By splitting out the existing shading into 2 phases that go through that intermediate structure, I'll ensure that when I later use that structure as a first intermediate pass through forward shading, the results are the same up to the precision of the encoded versions of those values, because in that intermediate buffer we'll be using Unit 8s or similar instead of the floats that we're using here. And we're kind of already doing some of that. So let's start at the top. Instead of this, I'm going to use surface dot. Oh, these names are not correct. I need to make them fit the naming convention. And now I've got to keep an eye on, well, let's see. So instead of base call, we need I'm gonna do this substitution first so that the code remains correct. And because my working memory in my own brain is quite small. But now, for instance, I think I'm going to make sure that it's not also modified. Make those const. For a start, go back to Unity. Something's unhappy. I'm trying to bring it up on stream. I don't know why. Sometimes the toggle. I've mapped a combined action on my Stream Deck to toggle an OBS source and bring a window into focus. There we are, doing that manually. So, what's it unhappy about? No member named base color. Oh, I called it base call. Is that all we need to fix? Yes. Okay, looking good. What is going on? So my Stream Deck, well, let's restart Stream Deck. Okay. So this is, there we are, that's the working shaders still, and that's visuals. Hello? There we are. That takes a while. I wonder. Why. I mean, for once, my OBS render times are good. My stream is stable. I'm rendering a comparatively small amount of small number of rays. I guess there's always some scuff. All right. the const. I don't need to worry about them. Roughness. So let's. So I'm just trying to make sure that the values aren't being modified further down. Okay, that works. Ambient. So that's the lighting. So the lighting is going to be separate from this surface determination. So also we've got the normal. So I'm going to be storing the world space normal. That seems to be what other engines do in general. There are good reasons for doing it in world space. It means that it's... I mean, there are trade-offs in terms of the precision and so on. In particular, working in a world space in your shaders means that if your camera is far from the origin, then you'll get precision issues. On the other hand, it means that you won't get potential... Well, I've not seen these myself, not written a shader where it would be relevant, but you could potentially get some swimming issues as the camera moves around. And it's easy enough to stay close to the origin in world space. Yeah. That's my understanding of it at the moment anyway. Do I use this tangent? No. I use it in the water shader. I don't need to store the UVs because we've already sampled the texture by that point. Actually, I'll bring this declaration down and initialize it all in one place. There's certain features of my model that, of my material model that, well, most of them in fact don't currently support texture maps. There's no reason why not. It's just I've not needed it yet. This is just an arbitrary, like, I might rearrange the flag later, but this is a float. What I need is receive shadow question mark. I'm not super clear on what implicit conversions are allowed in HLSL between different numerical types. I'll write it like this. It should be reasonably likely to work. and bitwise, or I'll do receives haze. So what I'm doing is compacting different features that are on or off into a single integer with bits enabled or disabled. The worst trap that I set for myself when making my keyboard was that I accidentally turn on insert and caps lock when I'm doing certain combinations of things, and I also never quite remember how to actually intentionally turn off insert mode, and that was caps lock. There we go. And because I'm not 100% sure on operator precedence, do that. In the book Numerical Recipes in C, the authors suggest that not knowing operator precedence by heart is unacceptable, and I think they said something like you should be reciting the operator precedence rules every day when you brush your teeth. I think given people work in multiple languages and I think it's better to have your code be obvious for someone who's less familiar with the language than to rely on everyone perfectly knowing the operator precedence. Yeah, emissive only arrays. That feature's not like really in use right now. Specular. Did I already do roughness? Yes. Let's move that down. So right now all of these are just copies of the material variables, but they could also involve a texture lookup or a procedural material, and at some point the water and the thrust animated texture are procedural materials in my scenes, so I'll have to handle that slightly differently. Alright, I think that's correct.
Winds southerly at about 15 with gusts of 25 miles an hour. Barometric pressure 30.00 and is rising. And no precipitation. We're about a half inch behind. Correction, half inch.
I'll remove the image-based lighting feature for now. I need to rethink how it's handled anyway. I'm also not sure about returning a struct versus passing it by reference. In terms of performance zone in HLSL. I think the ray intersection is used for downstream rays and is not used for figuring out the surface information. Interpolated attributes is used for the surface information, but not else. Right, and so now after this point in the function, I'm going to make sure I've got no references left to any of these things. Normal is a good one actually. Instead of that, I'm going to use surface normal. Oh, right. All right, that's an interesting thing to think about. So there's an important distinction to be made between the shading normal at a surface point and the geometric normal. The geometric normal is the normal of the real mesh geometry. And the shading normal is what you use for determining the shading, how much contribution from a light, depending on its angle to the surface, or reflections or things like that. When you cast a reflected ray from a surface, you want to displace it away from that surface by a small amount in order to prevent self-intersections. And how much you need to displace it by in order to avoid self-intersection due to numerical inaccuracy is something that was determined by a write-up in Ray Tracing Gems, one of the Ray Tracing Gems books. I think it's in here. I've got the implementation. Ray Tracing Gems 1, Chapter 6. So this is this has to be the geometric normal that we displace by. Because if you offset the ray against the shading normal, that might be at a wildly different angle than the real geometry. For example, on my mist shader, on my water, on my ocean. Oh, there's a compile error. It's not going to work. I've got the water waves going off at all kinds of different angles, but the true surface, the geometry, is just a flat plane. So in my shader, in this one we only deal with the geometric normal. But when it comes to doing deferred shading, we definitely need the shading normal available. And I have not seen, I mean, I'm not doing stuff in exactly the same way as a normal game engine would anyway, but I'm wondering, do I need to store the geometric normal as well, just for this displacement? Because it does make a visual difference. It greatly improved the shading of the ocean surface when I put in that implementation from Ray Tracing Gems. Let's store it for now. I think it's safer than forgetting about it. So I'm going to split that between shading normal, and I'll note that it's world space, and geometric normal. Do this. And for now, for this material, the shading normal matches. What am I doing in the water shader? So the mist shader is defined in here. That's the sky and water, procedural material water. Okay, it's just not using the closest hit shader function tool, closest hit surface function tool. Should probably refactor it to emphasize the commonalities of the model, but that's fine for now. So these are just future proofing for the moment, and it's this way I won't forget that there's both of them, even if I figure out a way to not need one of them. This one's the shading normal. So whenever we do a onward raycast, that'll be the geometric normal. Whenever we're doing lighting calculation, that'll be the shading normal. This is going to be a very exciting stream because at the end of it, either it'll be completely broken or it'll look exactly the same. This is to do with the shading normal. This one's the geometric normal. Wait, no, that's right. In this case, we're refracting, so we're sending the ray into the mesh, and we need to offset in the opposite direction. Good. That's all the uses of the normal. Now look at the flags next. We'll have to do some extracting. Oh, hold on. Actually, for these feature flags, I'll leave them because I'll lose the performance benefit of the branch being compiled out. So I'll just remember to I'll think about it later. Surface luminosity, easy enough. Surface metallicity. Surface IOR. Diffuse. I could do a search replace, but this way I'm actually looking at all of the uses of it and can think about them. Some of this code is factored in a way because I was thinking of a different way of splitting out ray tracing passes. But the idea I had didn't seem to be used anywhere, and I don't think would give that much benefit. Maybe. It's not how you spell that word. Surface reflectivity. I'm glad you're enjoying it, Lars. I think that's everything. Alright, what are the compile errors? That is a lot of errors. Undeclared identifier surface. Oh. Easy enough. Right. UVs. Well, that was not a lot of errors. It all looks fine. I heard a notification somewhere. Was that part of the... That might have been the Cable 2 sound alerts. I still have those turned on. It was either the music or the Cable 2 sound alerts. Which I should have turned off, but this stream, those are off now. Well, that all worked. Oh, sorry. I don't know why this... Why is this the thing that doesn't work? The switching... The toggling of sources in OBS via the Stream Deck should be well-established technology. Alright, so yeah, shader's all working. This is pretty chill doing this on stream, but it's also way slower because I'm talking through what I'm doing. Yeah, look at me go. What am I doing in the code now? So we can hoist this to the top because it's not dependent on any of the other code. And now let's find all the places that call this. Let's make a function shade surface. And move most of the implementation in there. And now this call is just like I said, we've split it into two phases. Shade surface. Ray intersection. Interpolated, no, sorry, surface. Many style guides would probably say that my parameters are the wrong way around because you should order them by in, out, and out. Just as a readability thing. I'll do that for shade surface. Although, I wonder whether there's another consideration to do with the I know that these tags are called like semantics in shader language. I don't actually know much about what they do, whether they're just a hint to the compiler or something more important than that. I'll try it like this. Wow. Why is that so unhappy? What was the error? Unknown type. Oh, I'm just misspelling. Bidirectional reflectance distribution function. BRDF. 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 Interpolated attributes. Oh, okay. Yeah, let's pass these in. And in some instances, we'll be reconstructing that as well from... Or maybe we'll have two versions of this. What do we use them for? In this case, it's just for the position. So maybe I'll pass in the world space position at this point. Of future bits of code. Let's hoist all of that out. All right. So now, what have I done? There we go. Now I want to find places where we call closest hit surface, and I will inline this code because I think this particular function is no longer useful or interesting. Of course, there's a lot of repeated code in each of the shaders, but I will in due course be refactoring it further. What's this? Oh, the portal test. Yeah, a lot of these shaders are doing weird stuff anyways. The portal test one is creating, portals like in the game Portal or like in the original Prey. It does it by creating material that shoots out subsequent rays off somewhere else at an offset in the world. It was just a test, and it works, you know. I don't have an application for it currently. I didn't make it in a way where you can author it sensibly. I just snapped a constant offset in there and checked that it worked. Are we still happy? Everything still, yeah, seems to be working. Good. That's actually as much as I planned doing for the stream. It's a very small amount of work, well defined, and so it only took 1 hour 45 minutes to do this simple refactoring. There are still things to think about, like the geometric versus shading normal, how to deal with the flags in a better way. This position will be reconstructed in different ways, but ideally the shade surface part would be callable from either the the conventional ray tracing pass, or from the ray generation where we shade the G buffer. Yeah, it's working. We can see it's working. As promised, I did a bunch of stuff and it looks the same as before, but the code is better factored now. It's working towards a future hybrid renderer that will look the same but be higher performance, because we're avoiding a lot of the ray casts for these initial rays. Alright, I'm going to wrap up here, I think. Let's see if there's anyone to raid. Faces are being raided and rays are being traced. Well, Narcoleptic Bat is doing some Unreal Engine development, so it seems like an appropriate thing to raid him now. Let's see. Oh, well, thank you for hanging out. I feel like I'm not actually that good at explaining these things. And it is hard to know what level to explain at as well for your audience. But it would be... I would like to do a proper walkthrough of everything in a more systematic way at some point. Be involving slides. Yeah, so with that said, it's time for me to go. If you like me have caught the Millennium Bug, make sure to watch the next stream. Find me elsewhere on the World Wide Web by clicking on the links below the video. I've been Millennium Cyborg, keep that future vibe, and I'll see you in the world of tomorrow.
And we're going to transform from world space to local space. You can see now each of the objects.
Hello, Raiders. Welcome in. Let me pause this for a moment. How's it going, Cyborg? Thank you so much for the raid. How are you doing? How did your stream go? Was it successful? I think I saw what you're doing and then I completely forgot. Oh, you're doing development